Hello students, welcome to our channel. Today we are going to study complex number. Complex number chapter number 3 class 11. Here in this we will deal with the topic that is logarithm of a complex number. In the complex number we studied about iota. Iota that is under root of minus 1. Here we will deal with the property of logarithm of a complex number. That if in a complex number we get a logarithm, so how to solve it? So let's understand logarithm of a complex number. Here let's consider that z. We usually denote a complex number by z and that is denoted as x plus iota y. Z we usually represent as x plus iota y, which is a complex number whose modulus amplitude form is, we know it is equals to z equal to r cis theta. Students, here I want to tell you that if you have here x plus iota sin theta, so we write it as cos theta plus iota sin theta. So as you join it, cos and sin, we get here cis, cos and then iota and sine and then theta, right? So this we are writing this r into this complete, and here it is r into iota theta, right? R e raised to power iota theta, right friends? So here we are saying z we denote as r cis theta, or you can write r as it is, and cis theta we are writing e to the power iota theta, right? Now we are, what is r? R is under root of x square plus y square, right? If we say x equal to cos theta, y we are saying it equals to sin theta, right? Now this is r cos theta, this is r sin theta. So this is equation first and this is equation second. Now square it. X square equal to r square cos square theta, right? And y square equals to r square sin square theta. Now add them. After adding we get x square plus y square equals to r square cos square theta plus r square sin square theta, right? Now in this we have x square plus y square, it equals to r square common, cos square plus sin square is 1. So value of r comes equals to under root of x square plus y square, right? So this is what we derived here. Now in these two equations, divide second equation by first. We have here r sin theta divided by r cos theta. This is equals to y by x. R with R cancel out. Sin by cos, that is equal to tan theta, which is equals to y by x. Theta comes equals to tan inverse of y by x. So this is the value of theta here. So this is what we derived here. Value of r, we are saying value of r is equal to under root of x square plus y square, and value of theta that is equal to tan inverse of y by x. Now z equals to r e to the power iota theta. Take log on both sides. What we are going to take? We are going to take logarithm. Logarithm both side. So as you take log z equals to log of r e to the power iota theta. Now students, we need to understand the property of logarithm. We say log m into n equals to log m plus log n, right? If we have any terms which is in multiplication, two terms that is in multiplication, and then we apply the logarithm on these two multiplication value, then it will be separated log a plus log b. So here we are writing log of r plus log of r, here this one, plus log of e to the power iota theta, right? Now log of, what is value of r? Just substitute it under root of x square plus y square and plus e iota theta, right? E with e cancel. Why it is so? Log of, we are saying e to the power iota theta divide by, this is with the base e. So I am writing here log e. Now if any term you see with the power, so it is here formula n log m. So I am writing iota theta into log e divide by log e. Log e with log e cancel. So this is the remaining part, that is iota theta. Now again with the same formula, we can write log of under root of x square plus y square, right? This is here. So log of x square plus y square with the power 1 by 2. We can write it. And this formula says that take the power in the starting, right? As a multiplication. So if you take this 1 by 2 here, so it's 1 by 2 logarithm of x square plus y square, right friends? So this is what it is written here, 1 by 2 log of x square plus y square and plus iota tan inverse of y by x. So this theta value we are replacing here, tan inverse of y by x. Now logarithm of x plus iota y comes equals to half of log of x square plus y square plus iota tan inverse of y by x, right? Kabhi bhi you find that logarithm of any value, so just simply by this formula we derive it half of log of x square plus y square. Take the real value square plus imaginary value square plus iota tan inverse of imaginary divided by real, right? Now put x equal to 0. In this above equation we put x equal to 0, y equal to 1. In above rule we get here log of iota. This comes equals to 0 plus iota into 1, right, is equal to half of logarithm of, here we have 0 plus 1, this is 1, plus iota tan inverse of, this is y is 1 by 0, right? Log 1, that is 0. So we get here iota as it is, right? Tan inverse 1, it is equals to pi by 2, right? So value of this comes equals to iota pi by 2. Now we are going to find out a relation between trigonometric function and hyperbolic function. We know e iota theta, that is cos theta plus iota sin theta. E minus iota theta, that will be cos theta minus iota sin theta, right? Only you need to displace the value here, plus iota theta, we get here minus iota theta. Now adding equation first and second, we have e iota theta plus e minus iota theta equals to, as we add it, these two value will get cancelled and we have here 2 cos theta. Now e iota theta plus e minus iota theta divided by 2. This is a multiplication. Take it in denominator. It comes equals to cos theta. So this ex plus e minus x by 2, we say the value is equals to cos of x, right? According to hyperbolic function, we have this cos of x, right? Cos hyperbolic x. So we get here cos iota theta. It equals to cos theta. Here subtracting first and second, we get a subtraction and then we get here 2 iota in sin theta. Now this is the formula of sine hyperbolic x. So we are writing sine hyperbolic iota theta equals to iota sine theta. If we have any value with a hyperbolic, so simply this iota comes out and then sine theta, right? So don't get confused if you have any hyperbolic function. Now complex number as a rotating arrow in a argent plane. Now we are taking two complex number. What are these complex number? One that is Z1, another that is Z2. With that we have a position of these, that is P and Q. Now we are going to here take in argent plane. So we are taking the x-axis and y-axis such that OP equals to OQ equals to R. So these Z1 and Z2 we are taking here, OP equals to OQ, and these both have a same values, that is R, means modulus of value of that is R. Now Z1 R cis theta phi, Z2 here we are taking POQ equal to theta, one value that is with the phi, and POQ angle we are taking here theta, right? Angle between P, this one POQ, this is theta, and here angle with the x-axis of this Z1, that is phi. So that's why we have written here cis phi, right? From diagram, angle XOP equal to phi. XOQ comes equals to, if this is phi, this is theta. So complete is XOQ. XOQ means this total will be theta plus phi. So this is theta plus phi. Z2 comes equals to R E iota with angle. Angle is theta plus phi here. Right, students? Now Z2 comes equals to E iota theta R E iota phi. Right? How we are writing? We are separating it. We can separate it? Yes. R E, this is I am writing I theta into E I phi, right? So this value with this value we get separate, we take it as a separate value. Now this value is equals to, ये value क्या है? This is R Z1, right? So Z2 comes equals to E iota theta into Z1. Now Z2 is equal to E to the power iota theta into Z1. Therefore, multiplication of Z1 with E iota theta. Rotate vector OP through an angle theta in anticlockwise direction. Similarly, multiplication of Z1 with E minus iota theta. You can find it? Yes. We'll rotate it in a anticlockwise, right? Clockwise. The previous one, this is anticlockwise, right? So if you take minus iota theta, it will be clockwise. Now, here, rules. Multiplying a vector by RE iota theta, result increase in length by r times. तो उसकी लेंथ कितनी हो जाती है? r times increase हो जाती है. And rotating through theta in the positive direction means that we are rotating in the positive direction. Dividing a vector by r e iota theta, changing the length by 1 by r times, right? If you divide it, it will change the length and rotate through in the negative direction. Then we say that we are rotating it in the negative. Means multiplying means positive direction, dividing means negative direction. If we are multiplying, then length increases. If we are dividing, then it changes 1 by r times. Now multiplication by iota cause rotation through pi by 2 in the positive direction. If we multiply this by iota, then it causes rotation, and this rotation causes through pi by 2. And if it is minus iota, it causes rotation pi by 2 in the negative direction, right? Now vector notation from the diagram, if magnitude of AB goes to magnitude of AC when rotated through an angle theta in the positive direction, thus we say this AB with the value Z1, Z2 and Z3. So if we rotate it with the angle theta, we say unit vector is equal to AB unit vector E iota theta. As we know the formula, we have here unit vector is equal to, we say vector equal to, what is the formula of vector? Vector is equal to unit vector into the magnitude, right? Magnitude. So if we want to find out the unit vector, it will be vector divided by magnitude, right? So just understand this formula. If we have AC as a unit vector, so unit vector comes equals to vector by magnitude, right? It is vector divided by magnitude. So here AC vector by magnitude AC, it equals to AB magnitude divided by, AB vector by magnitude of AB E iota theta. Now, how to find out the vector here of AC? AC, that will be, it is here Z3 position vector of C minus position vector of Z1, right? Position vector of A. So Z3 minus Z1 divided by magnitude of Z3 minus Z1. Here Z2 minus Z1 divided by Z2 minus Z1 into E iota theta. Now geometrical representation of sum and difference of two complex number. Z1 we are saying x1 plus iota y1. Z2 it equals to x2 plus iota y2. These two are complex number denoted by P of Z1 equals to x1 y1, Q of Z2 equal to x2 y2 in the Argand plane. Now this is complete one. P and Q, two vectors, right? Two complex number. Now complete the parallelogram. We have here this OPRQ, right? As we are having these two values O and P. So if you take the complete one, OPRQ will be the parallelogram, right? Now in this we have R vector as a resultant, and that's why it is here written Z1 plus Z2, right? The values if we are taking, so here it is a parallelogram, so you can take as a negative value if you are taking equal values. Then q dash is denoted by, if this complete is z2, this will be minus z2. Now also complete the parallelogram OPR dash Q dash. This will give you the complete value, and then resultant will be here, this is Z1, this is minus Z2. So this is the resultant, sorry, this is the resultant, and resultant value will be Z1 minus Z2. Now sum of Z1 plus Z2 from figure, it is a parallelogram. Diagonals OR and PQ bisect each other. So midpoint of OR equal to midpoint of PQ, right? Midpoint of OR will be O plus X by 2. We have a formula, right? If we have X1, Y1 and this is X2, Y2. So midpoint formula is X1 plus X2 by 2 and another one Y1 plus Y2 divided by 2. So same here, if we have here OR, right? OR. So origin we have 0, 0 and this is X comma Y. So this will be X plus 0 by 2 and here y plus 0 by 2, right? So midpoint of PQ will be x1 plus x2 by 2 and y1 plus y2 by 2. Now compare x5 equal to x1 plus x2, y1 plus y2. So rxy represent z1 plus z2. Now take the difference, as OPR dash Q dash is a parallelogram. Again diagonal bisect each other, so mid value will be same. Yes, midpoint of OR dash will be equals to midpoint of PQ dash, right? Now here O plus R dash by 2 is equal to P plus Q dash by 2, means R dash comes equals to, here it equals to P plus Q dash. You can take the values also if you want. This will come here x1 comma y1, right? Okay, now z1 minus z2, it equals to R dash equals to xy represent z1 minus z2, right? Now note in triangle OPR, right? We have here OP plus PR greater than equal to OR. That is OP, which is modulus of Z1, PR modulus of Z2. So this value, the sum of this value is always greater than OR, right? Means greater than Z1 plus Z2. Triangle OPR according to the triangle property we are saying, right? Now modulus of Z1 plus Z2 means less than equal to modulus of Z1 plus modulus of Z2. Now replace Z2 by minus Z2. We get the value here. Z1 minus Z2 less than equal to Z1 plus modulus of minus Z2. Now we have here Z1 minus Z2, that is less than modulus of Z1 plus modulus of Z2. Right, students? Note 2. In triangle OPR gives OR plus PR greater than equal to OP. In a parallelogram, we know the opposite sides are equal, so PR equal to OQ. So here we are writing at the place of PR OQ, right? At the place of OQ we are writing here PR, right? Now here OR plus OP is greater than equal to OQ. So OR greater than equal to, take this OP that side, right? OP that side, OQ minus OP. Now from equation first and second, we are saying this is greater than this is greater than this. The both values we are having positive and negative sign. So OR is greater than plus minus OP minus OQ. From it we say OR. What is OR? It is modulus of Z1 plus Z2 greater than equal to OP. It is modulus of Z1. OQ, it is modulus of Z2 with a negative sign. Now note 3. Above rule combined with a single result, it is, here we say, if we have a modulus of Z1 minus modulus of Z2 less than equal to modulus of z1 plus z2, which is less than equal to modulus of z1 plus z2, means we can separate the values, right? We can separate the values. Now we have some MCQs. Log of x plus iota y. According to it, we have half of log of x square plus y square minus this and this. So we have now only found the value. We have derived it, that if we have log of any value, then it will be equals to half of log of x square plus y square plus iota tan inverse of y by x, right? So simply, if we have log of, consider log of 2 plus iota 3, right? So I am writing half of log of, it is 4 plus 9 plus iota tan inverse of, it's 3 by 2, right? Half of log of logarithm of 13 plus iota tan inverse of 3 by 2, right? So this will be the answer. Now modulus of z1 plus z2, it is less than modulus of z1 minus z2. So simply we have modulus of z1 plus modulus of z2, right? If two values combined, we can separate them. Now, geometrical interpretation of product of two vectors, complex number. Geometrical interpretation of a product of two complex number, we have p of z1, it equals to r1 cis theta 1, q z2 r2 cis theta 2, be the two complex numbers in the Argand plane. This we consider p and q. Now, here OP R1, right? Position vector of OP and with the angle theta 1. Then OQ, it equals to theta 2. Now OA we consider equal to 1. So that A with the position vector 1 comma 0 is in a real axis, right? We know x-axis, we have y0. So this is A10, join A with the P, right? Now construct OQR similar to OAP, right? We have another triangle OQR. Now such that QOR is equals to AOP, means angle will be same. So this one is also theta 1, and OQR equal to OAP. So here we have this angle. This angle is equals to this angle. So another, so that will be same only. Now as triangles are similar, see we have an angle property, right? This angle is equal to this angle. Another one, here we have this angle is equal to this angle. So by angle criteria, the two triangles will be similar. Yes. Now sides will be in ratio. We know OA equals to 1. So 1 by OQ equal to OP by OR. Here, from here, we are finding the value of OR. So OR comes equals to OP into OQ. OP value is R1 and value of OQ equal to R2. Also, XOR comes equals to XOQ plus QOR. So here, XOR equals to theta 1 plus theta 2. Implies here R represent the complex number, right? So we say R1 R2 cis theta 1 plus theta 2 means it is Z1 Z2. R जो है वो क्या represent कर रहा है? R1 R2 cis theta 1 theta 2, right? Plus theta 2. Now geometrical interpretation of quotient of 2. There we have taken the multiplication. Here we are taking the quotient of two complex number. So if we have a P of Z1, R1 cis theta 1, QZ1, Z2, R2 cis theta 2 be the two complex number in the Argand plane. Now, here, if OP equal to R1, OQ equals to R2 with the angle theta 2. Now, OA equals to 1, A with the value 1 comma 0 is in a real axis OX. Now, draw a line OR in the figure here in between it, right? Such that POR. Here POR we are considering theta 2. In the previous one we have taken theta 1. You know? So here we are taking POR equal to theta 2. Draw the line here. So angle OAQ. See here. OAQ. This angle we are taking here as a same. Right? So again we say by which property? Congruent similarity property. We say triangles will be the similar and the sides will be in ratio. So R1 by R2 comes equals to OR divided by 1. From here we can find OR R1 by R2. So XOR we find. XOR, just check it. XOR, how to find out? This is XOR. XOR. From here we can find XOR, right? So how to find it? Let's derive. This is here XOP minus PR means theta 1 minus theta 2. So we say the R, capital R, represent the complex number, that is R1 by R2 cis theta 1 minus theta 2 means Z1 divided by Z2, right? So students, from here we derived the multiplication and division. Now miscellaneous result, if we have any value with a square, modular square, it will be z1 square plus z2 square plus twice of real value of z1, z2 modulus. Then we have here twice of z1, z2 cos of theta 1 minus theta 2, right? Now only we have derived it, so that's why. z1 minus z2 whole square, it is z1 square plus z2 square minus will come. And it is z1 square plus z2 square minus twice of modulus of z1, modulus of z2, cos of theta 1 minus theta 2. Where theta 1 is the amplitude of z1, theta 2 is amplitude of z2. Now, let's derive the proof of it. If we have z1 plus z2 whole square, so how to write it? If we have a two values square, it will be z into z bar. Same, z1 plus z2 into z1 plus z2 modulus. Sorry, conjugate. So conjugate we can separate z1 plus z2 according to the properties. Now multiply z1 z1 bar plus z1 z2 bar, z2 z1 bar, z2 z2 bar. Now in this we have two values with the same. So z1 square, z2 square, this z1 z2 bar plus z2 z1 bar, right? This is z1 square plus z2 square plus twice of, this is what? Real values of z1 z2 bar, right? Now here z plus z1 bar, it equals to twice of real value of z. Let z1 equal to r1 cis theta 1, z2 equal to r2 cis theta 2, z1 equals to r1 cis theta 1, z2 bar equals to r2 cis. Here we change the sign of this angle, right? It is minus theta 2. Now real value of z1 z2 bar comes equals to z1 bar modulus z2 modulus into cos of theta 1 minus theta 2. Now z1 z2 bar equals to, here we are writing the values, right? It is r1 r2 cos of theta 1 minus theta 2. Now real value of z1 z bar z2 bar equals to r1 r2 cos of theta 1 minus theta 2, right? This complete value comes equals to this. Now real value of z1 z2 bar equals to, this is modulus of z1, modulus of z2 cos of theta 1 minus theta 2. R1 and R2 are here modulus of Z1, modulus of Z2. These are the position vector. So now the above result in 1 is gives modulus of Z1 plus Z2 whole square is equal to, we have here Z1 square plus Z2 square plus twice of Z1 plus Z2 square plus twice of Z1 Z2 cos of theta 1 minus theta 2, right? We will take the values here, right? Now, thus 1 and 2 will give, what they will give? We got the final result here. What is the final result? It's modulus of z1 plus z2 whole square. It is equal to z1 square plus z2 square plus twice of real value of z1 into z2 bar, right? We will derive it properly so that we get the result. Now this is z1 square plus z2 square plus twice of z1 z2 cos of theta 1 minus cos of theta 2. Now this is proved, right? Similarly we can prove the other result. We can find it? Yes. Here we have the another value. Now we are coming to the summary of it. right? What we have derived, what we have find out the values of each and every value, that we will see here. What are the results we derived? First, iota square, which is equals to -1. Iota value it equal to under root of -1. If we have z into z bar, right, conjugate, then it is equal to modulus of z square. If we have addition of two values, z plus mod conjugate of z, that will give you twice of this. You can find it here. If z is equal to x plus iota y, right? Conjugate of this is x minus iota y. So simply we say this with this cancel out and it equals to twice of x. So what is this x? This is a real value of z, right? Now next, z minus z bar, that is equal to twice of iota imaginary value of z. Z is real. If it is real, then z equals to z bar only. अगर imaginary part नहीं है तो conjugate दोनों का same होगा. If it is purely imaginary, then z plus z bar equal to 0. If z equal to f of z1, then z bar equals to f of function z1 bar. If z1 plus z2 bar we have, then we can separate these two values. It is less than equal to modulus of z1 plus modulus of z2. Now, if we have modulus of z1 minus modulus of z2, then what to do? Then it will be less than equal to z1 plus minus z2, right? And it is less than equal to modulus of z1 plus modulus of z2. If z equals to x plus iota y, then we have under root of x plus iota y equals to plus minus under root of modulus of z plus a by 2 plus iota modulus of z minus a by 2. This is what? Square root, right? Square root कैसे लेते हैं? We know the formula now. Now, if we have z1 plus z2 whole square, now only we have derived these two formulas. Just understand it. Now, if we have cos theta plus iota sin theta, it is cis theta. If we have x plus iota y, then it is r cis theta and it is equal to r e to the power iota theta, which is the polar form. If we have e iota theta, we can write it as cis theta. If we have e minus iota theta, then it will be cis minus theta. 1 by cis theta is equal to cis minus theta. If we have two values with the product, so we can write it as cis. The two values we combine, alpha plus beta. If we have in division, then subtract it. Amplitude of z plus amplitude of z bar, that is always equal to 0. Sum is equal to 0. And if they are in product, we say amplitude of z1 plus amplitude of z2. If they are in division, then we subtract them, right? Now, concept of rotation, we derived unit vector of AC is equal to unit vector of AB into E iota theta. That will be vector divided by magnitude. So, it's Z3 minus Z1 by Z3 minus Z1. Here, Z2 minus Z1 divided by modulus of Z2 minus Z1 into E iota theta. So, these are the results we need to understand so that we can use in the another questions. And upcoming questions, they will be very important for you. If you like the video, please share with your friends. Thank you. Bye bye.